Hi everyone. So today we're going to work on trigonometric ratios. Trigonometric ratios. Specifically, we're going to work on our magical six, our sine, cosine, tangent, cosecant, secant, and cotangent. And we're going to talk about how we come up with them and what's the relationship and how do we write them as we start. Okay. Whoops, ratios, not rationals. I did that in the last class too. For some reason I wrote rational. Co ain't rational. Ratios. That's an S. Okay, ratios. Now, okay, so let's talk about the idea of trig. The word trig means three, like we talked about before. And so we're looking at three-sided shapes and the ratios of those three-sided shapes. So once we're going to start off right now with, they're going to be right triangles. I'm going to draw a right triangle. I'm going to call this theta. You can call it a letter A if you want also. And we're going to label these sides as 3, 4, and 5. Now, previously, we had talked about the Pythagorean Theorem, and the Pythagorean Theorem allowed us to calculate that any three sides, wait, the missing side, given any two sides of a right triangle. To say this again, I can also prove that this is a right triangle if this was true. Okay? So because we have a definitive way of describing the relationships of three triangles, we can come up with some rules. And the first rule we're going to come up with is we're going to talk about something called sine. Sine theta, oops, sine all the same size. Sine theta is equal to what we would say opposite over hypotenuse. And these are the ratios. A ratio is always considered a fraction. You can see ratios are another way of saying fractions. It's also a big deal of the idea is comparing. What is the ratio of boys to girl? What's the ratio of rich to poor? What is the ratio of A's to B's? Passing to not passing. So whenever you're doing a ratio, you're always comparing. And that comparing will give you a number, whether it's greater than or less than 1. So what we're going to do here for sine, sine is just comparing the opposite over the hypotenuse. Now let's talk about these sides of a triangle, which would be opposite and which would be considered hypotenuse. Now, if I am here at theta, what side would be opposite of theta? Would 5, 3, or 4 be opposite of theta? If theta was me, well, 3 would be adjacent to me, 5 would also be adjacent to me, so 4 would be the most practical choice. So 4 is my opposite side. And you can always just draw an arrow to say, hey, it's on the opposite side of my angle. It's also the side that I open up to. See, I'm opening up to the 4. A right triangle always has a side called hypotenuse. Hypotenuse is the opposite side of the right angle. So this is my hypotenuse. And then, well, we have one more side. That's going to be called adjacent. And adjacent is right next to my angle. See how it's right next to me. It kind of doesn't leave my side. You could try to claim that 5 is also an adjacent, but then that would just be really confusing. So each of these three sides of a triangle has a name, and that's going to be adjacent, opposite, and hypotenuse. And they all have a spot, whether it's opposite of my angle, adjacent to my angle, or hypotenuse that never changes. So in this case, my opposite would be 4, and my hypotenuse would be 5. 4 over 5. Now, one thing we want to be aware of is that this is going to help us later because remember triangles from geometry? You could draw triangles in a lot of different ways, but we had a rule. We said that let's call this A and B. I'll call this side, this huge side, C and D. And we had a rule in geometry where if I say A is related to B, it is the same ratio as C has to D. Remember, if triangles are related triangles, that means they have the same relationship. So the fractions would be the same. And that's what really is going on here. We're saying that sine of theta, and we're going to see this a little bit later, that no matter how big I draw this triangle, it will always have the same relationship of 4/5, as long as theta is the same. So we'll get more into that later. This is kind of a sneak peek. So let's give you guys another one. I'm going to draw a triangle in a different way. Okay, I'm going to call this 10, 6, and 8. I'm going to put theta in this corner here. Theta is in my lower right-hand corner. Well, let's label the three sides. Which side would you consider opposite? Which side would you consider adjacent? And which side would you consider the hypotenuse? Well, the opposite of my angle is over here. That's my opposite. OPP, opposite. And then hypotenuse is always opposite of my right angle. And adjacent, hey, this guy's right next to me. This is my adjacent. So opposite is always on the other side. Hypotenuse is always opposite of the right angle. And adjacent is always next to me. So if I ask you this question again, follow up, what's the sine of theta here? We can say opposite is the side 8. OPP over HYP is 8 over 10, which actually reduces down to 4/5. Now, you might say, Mr. Ko, both those answers are the same. Well, they are the same. And what that should lead us to is to also say that the angle would be the same. So even though 6, 8, 10 is bigger than 3, 4, 5, it turns out they're actually the same triangle, just related to each other. If I say that this is, let's say this is 3, 4, and 5, the large triangle would be 6, 8, and 10. And they would share a common angle. Okay, so this is kind of weird. So going backwards, talking about the sides versus starting off with angles, that's just a way to start. Okay, now we have a couple more ratios to talk about. We said we had 6 of them to go through, so let's go through all 6. So I'm going to write a table for you guys right now. We're going to say sine SINE is abbreviated SIN, and the sine of theta is equal to opposite over hypotenuse. The cosine, abbreviated COS, if you notice, it's actually just the front 3 letters. It's not sin. It just turns out it's just the first 3 letters, say sin, sine. This is adjacent over hypotenuse. Now, to help you guys distinguish the two, these are the main ones that you want to make sure you don't flip out over, is if you don't want to sin, you should stay opposite away from sin. Co-buddy, cosine, see how it's co-sinning, right? Well, that's your friend in crime, that he's adjacent to you. So your co-buddy, your co-pilot, your co-worker is adjacent. And then we have one more called tangent. And again, we're taking the abbreviation TAN. Tangent of theta is opposite over adjacent. Tangent has nothing to do with hypotenuse. It went off on a tangent. Now, real quick, just to say this, you guys have also learned this in geometry as SOHCAHTOA. SOHCAHTOA. Okay, and this is the name of a Native American princess. This was Pocahontas's little sister, SOHCAHTOA. She was slightly crazy. She was walking around drawing triangles everywhere. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I personally don't like SOHCAHTOA too much because it's just one of those things you have to memorize like an addition. I feel like if I taught you sine first, that's going to be opposite. If sine is opposite, sine is opposite. Sine sounds bad. I should stay opposite from it. And then cosine is adjacent because co-buddies. And tangent has nothing to do with hypotenuse. But that's fine. SOHCAHTOA is helpful. You can write this always on the test. Remember, on the test, it is not cheating if you write notes after the test has started. If after the test starts, you write SOHCAHTOA, that's not cheating. If you write it before the test has started, that's called cheating, okay? So time is a big deal. All right, let's go through our additional ones. And sometimes this is called reciprocal. Reciprocal identities. And this would be cosecant, whoops, let me write that out. Cosecant, we have secant, and then tangent. Cosecant, secant, and whoops, not cotangent. See, we have to add that co in front. So secant is a reciprocal of what we said back there, and we can't use the first three here, so please understand we can't do that. That would be a bad thing. So I'm going to highlight this in. This is not going to be COS. That would be confusing. We call it cosecant. Just kidding. This cosecant is abbreviated CSC beta. Cosecant. And this is going to be hypotenuse over opposite. Only difference, please understand. Only difference is that it is just the reciprocal. Secant is just the reciprocal of cosine. So SEC, secant is hypotenuse over adjacent. And the cotangent is COT, is the reciprocal of tangent of opposite over adjacent is adjacent over opposite. And please don't overthink this. This is just really the 6 different ways we can write any combinations of sides in a triangle. If I draw you a triangle here, and I write opposite, adjacent, and hypotenuse, pick any 2, and you will end up with one of our 6. If I pick opposite and adjacent, opposite over adjacent is tangent. If I pick hypotenuse over opposite over opposite is cosecant. If I pick in random adjacent over hypotenuse, hey, adjacent over hypotenuse, that's cosine. So we have a name for every possibility given our 3 sides. In Algebra 2, you learn about permutations and combinations. This essentially is a combination. 3 times 2 times 1 gives us our 6 possibilities. So let's go ahead and move a little forward here. So let's give you guys another triangle. Let's say it's going to be a triangle. So if 3, 4, 5 is a popular triangle, is 1, 2, 3 a triangle? 1, 2, and I'm not going to write 3 there, but would 3 work? 1 squared plus 2 squared, would that equal to 3 squared? If this was a right triangle, now again, SOHCAHTOA, sine, cosine, tangent only work with right triangles. How can you have a hypotenuse if it's not a right triangle? You can't. That's why it only works for right triangles. Now, is this a true statement? 1 squared is 1, 2 squared is 4. Does that equal to 9? Not in this America. Okay, so that doesn't work. So what would this really be? 1 squared plus 2 squared is equal to blank. I don't know what that is. Squared. That's going to say 1 plus 4 is 5 equals to c squared. So c would have to be the square root of 5. Okay? So this is really the square root of 5, which is approximately 2 point nobody cares. 2 point something. But that's why we have square root of 5. So I don't have to write 2 point something. Square root of 5 is 100% great. Now, I want us to write what is the, let's do this. What is the tangent of theta? Oh no, let me call this something else. I'm gonna call it A. Call this A. What is the tangent of angle A? Now again, these are always gonna be angles for us, and angles of these triangles. It's acute angles. So if I look at A, the opposite of A is 2. Adjacent of A is, right next to is 1. And the hypotenuse is square root of 5. So we're just going to write that out, copying it. It's going to be OPP, opposite, over ADJ. It's going to be opposite is 2 over 1. Done. That's it. Super hard. What if I say, what about cosine of A? Cosine is adjacent over hypotenuse. So after I write it, I just need to look at the triangle. The adjacent of A is going to be 1 over hypotenuse square root of 5. Now, this is going to bring back some like scary algebra 1 memories, but am I allowed to leave square roots on the bottom? And the answer is no. We want to write that square root on top. For some reason, someone came up with an idea that this isn't a good idea. Can't leave square roots on the bottom. Can't leave your pants down. You can't walk around the house without your pants. So let's go ahead and put on our pants. So we're going to do this by multiplying the denominator by a square root of 5 to the bottom and the top. Pick up your pants. Reminds me of my son walking around. Hey, put back on your pants. My son is 3 years old and he's being potty trained. Oops, I shouldn't say this while being recorded. Oh wells. Okay, so we multiply the square root of 5 to the top and bottom and square root of 5 over 5. Now to help you out with that, 1 times square root of 5 is just 1 square root of 5. And square root of 5 times square root of 5. Since we have 2 square root of 5s, uh-oh. Did you freeze on me? Give me a moment. Nope, you didn't freeze on me. Oh, we're good again. Square root of 5 times square root of 5, it's, remember square roots look for pairs, and I do have a pair of 5s, so we can just write this as 5. Okay, let's keep on going. Let's ask ourselves, what would cosecant be? Cosecant of A. That's hypotenuse over opposite. Hypotenuse is square root of 5, and opposite is 2. Are we cool with square roots on top? Yes, this is done. And let's go ahead and finish off the rest. Let's do sine also. Sine is the reciprocal. Whoops. One cool thing is that if you have the reciprocal, just change it over. Oh no, there's a square root on this one on the bottom. Let's go ahead and flip it. This would be 2 square root of 5 over 5. Now, if you don't know the trick about moving square roots, you could show the work square root of 5 over square root of 5. And guess what happens at the bottom? It's no longer in a square root, and the square root is moved to the top. Now, let me show you the fast trick about this if you haven't realized it yet. If I write 706 over the square root of 3. This sounds terrible. The answer is 706 square root of 3 over 3. The fast way to rewrite this is just take it out of the square root and move the square root to the top. Because when you multiply by the square root, it's going to come out anyways, and you're just going to put it to the top. Pi over square root of 21. Move the square root to the top, and the bottom is free. Okay, if you don't know that trick, saves you a lot of time. We did 1, 2, 3, 4. We got 2 more to go. I got cotangent of A. It's adjacent over opposite. Get it? Because it's it's your co-buddy. I'm just kidding. No, don't think of it that way. And that's going to be 1 over 2. And then we have sine, cosine, tangent. We have secant. It's going to be hypotenuse over adjacent, which is square root of 5 over 1. So identifying a sine, cosine, tangent is going to be super important. It's one of our basic skills, but we want to make sure we can work on and get 100%. Because our next skill is we're going to use this to solve for the triangle, identifying which sine, cosine, tangent we need, and then setting it up so that we can solve it. Now, I'm going to ask you guys this follow-up question. What if I'm missing a side? What if I write this question? 4, 7, and I don't know. We'll call this angle A is up here. Let's take the angle A from on top. So I'm going to ask you guys what is the sine of A, the cosine of A, and the tangent of A. Followed by, I'm going to call this side B. What is the sine of B? What is the cosine of B? And what's the tangent of B? All right. So great. Sine is opposite over hypotenuse. Now let's see. Do we know what opposite is? Opposite of A is 4. OPP. OPP. That's not too good. This is opposite. And this is my hypotenuse because of the right angle. And 7 is my adjacent. Adjacent to A. Now, okay, let's do it. We need opposite is 4. Hypotenuse, I have no clue. But since this is a right triangle, thank you, Mr. Pythagoras, we can use Pythagorean Theorem. So we say 4 squared plus 7 squared equals to the hypotenuse. Make sure the only side that matters is the hypotenuse. Remember, the hypotenuse has to be by itself. So 4 times 4 is 16. 7 times 7 is 49, is equal to c squared. That's 50. 65 equals to c squared. So c is equal to the square root of 65. Now, I don't know if 65 has a square root. Not an easy one. So I'm going to draw my little box here. And that's the smallest number. I can divide 65. Well, for sure, 5. Let's do that. Now, remember, this is just an upside down division sign. That's really what I'm doing. 5 goes into 6 one time, remainder 1. 5 goes into 15 3 times. Oh, 65 is just 5 times 13. No pairs, no problem. We'll just leave it as square root of 65. So now our problem is that we have a square root of 65 on the denominator. And we just mentioned before our trick up here, remember? Just move the square root on top. 4 square root of 65 over 65. Can I reduce 65 and 4? Nope, that's our answer. Let's look at the cosine. The cosine is adjacent. Looking over here, the adjacent value for the triangle is 7. Hypotenuse is still square root of 65. Oh no, we have a square root on the denominator. Remember, just throw it on top. And we're good. Last one, tangent, it's opposite over adjacent. So I just copy the sides opposite and adjacent. Okay, on the right side here, sorry, we have the same idea, except we're looking for angle B. We're taking a whole different perspective. Can you see through my eyes? Can you understand me? Because we're going to change this around. And from angle B, our sides change. So if I'm standing here, right, B, What side would be opposite of B? Well, now that would be 7. This is my new opposite side. Hypotenuse has not changed, and adjacent is 4 now. So to be aware of that, we're going to say, okay, it's going to be 4. Whoops, sorry. Sine is opposite. Got to make sure you double check. Opposite over hypotenuse, which we can simplify to 7 square root of 65 on top over 65. This stuff could be really fast. Cosine is adjacent. Adjacent is 4. Hypotenuse is 65, square root of 65. Rewriting without square roots on the bottom. No square roots on the bottom, whoops. And then the last part here is our tangent is adjacent over, nope, a tangent is opposite, because we learned opposite first, 7 over 4. So the big takeaway here is we can find our sine, cosine, tangent if given just 2 sides of a triangle. If you give me 2 sides of a triangle, we can always find the third using Pythagorean theorem. And now we have all 3 sides, and we can describe our trigonometric ratios for that triangle.